Hello, my dear friends. Today we'll discuss a very important equation, equivalence between energy and mass, Einstein's E equals to mc square equation. You know, this is the only equation in physics that almost every person knows it very well. This is the only equation that everyone knows it, that energy and mass, they are convertible. Energy can be converted into the mass.
This event was the conversion of a high-energy gamma ray that kicked an electron out of an atom and was itself converted into two particles. The gamma ray photon does not show up in the cloud chamber because it has no charge. This is an example of converting energy to matter. The energy of the gamma ray photon had to be as great as the energy embodied in the two particles. For electrons and positrons, that comes to around 1,000,000 electron volts.
Or the mass can be converted into the energy. Both are interconvertible. This equation is so familiar. This is a familiar equation. It's probably worth asking the question, is this question as it seems is true? So this equation, the answer is this equation as it is not true. And we have to understand, it is actually a special case of some other equations. And what are those equations? And how it becomes a part of those equations? Let's understand. So this equation is actually a part of the other two equations. So let me tell you about those two equations. Okay, so this equation as it is not true, but actually the equation below looks pretty similar to like the above equation. And here, A is not mc square. Actually, A is gamma times the mc square. Now, question you will ask, what is the gamma? Okay, what is this term? This terms comes from the relativity. How? And the value of gamma is 1 upon root of 1 minus v square upon c square, where c is here constant, and this constant, the value of this constant is equals to the value of velocity of light in vacuum, and v is the velocity with which our object is moving with respect to us. Okay, you remember this value gamma? So gamma is a term that is ubiquitous in relativity, So this gamma is well known in relativity, okay? This is well known in relativity. And V is already, I told you, V is the relative velocity, mean velocity of the object with respect to u, right? This is what it is, gamma. Therefore, now the value of E becomes gamma, this is gamma, into mc square. You know, what is this m? M is mass of the object. When that mass is not moving, then when the mass is not moving, then its value is m. Okay, mass of the body when it is at rest. You know, this whole term, this represents also the mass, but that mass which is moving, when the mass moves, its velocity changes. When the mass moves, its value no longer remains small m. Now when the mass moves, its value becomes m upon the root of 1 minus v square upon c square, right? So you can consider it as the object's moving mass. One thing you keep in mind, that mass changes when the body moves approximately equal to the velocity of light. So this is the moving mass, right? Therefore, for object in motion, then we write E equals to gamma mc square, or moving mass into c square. Moving mass multiplied by c square. So if the object is at rest, if object is not moving, then you know, its velocity becomes 0, substituting here. So it becomes, the gamma becomes 1 only. Then now we are having the same equation, E equals to mc square. So I think you understand now, this equation is correct only when object is at rest, that it is not moving at all, then it is okay, its energy is mc square. But if the mass moves, then this equation becomes incorrect in that case. So gamma is 1 for object at rest. So E equals to mc square is valid, good equation, only for the object at rest. So whenever you take the reference of the equation, you must include the body at rest. If the body is moving, then this is the right equation. This equation is true for the object or the body is in motion, right? Because mass changes. For moving objects or moving bodies, the above equation is E equals to gamma mc square is correct. So E is equals to mc square, no problem, no doubt. Einstein famous equation, it is true or correct for the object at rest, for object not moving. Right? Now this is the graph. It shows the value of the gamma along y-axis, v upon c along the x-axis. You know, when v equals to 0, then this is a point, gamma having value equals to 1. When v is increasing, there is no change, or change is very, very less. You know, the change is very less. But reaching it here, you know, here, what it is special? Now velocity here, velocity of the object, it approaches to the velocity of the light. Mean velocity at here may be 0.8 times the velocity of light. Here it may be 0.9 times the velocity of light. Here may be 0.92 times the velocity of light. So if velocity approaches to the velocity of light, then there is a change, drastic change in the value of gamma. Gamma increases. There is an abrupt increase, large increase, only when v approaches to the velocity of light. For less velocity, if the velocity is less, there is no appreciable change in gamma. Even if the velocity is half to the velocity of light, even then, there is not much change in the value of the gamma. Remember, this gamma having good values when v tends to c. Okay? So this is how the value of the gamma. You know, gamma is what? 1 over root of 1 minus v square over c square. It seems to us this is the exact equation. But again there is some problem in this equation also. And what is that problem? Let we discuss. You know, already I told you E is equal to gamma mc square is nice equation which is applicable for rest masses as well as for moving masses. Now look one thing. If E is assumed to be constant, then you making the mass smaller and smaller, but you want the same energy. Okay, you are having the particle of mass lesser and lesser, and you are interested for the same energy, then gamma should be higher. The value of the gamma should be more, or the value of the gamma should be such. It has to increase. Gamma has to increase. If you are making m smaller and smaller, then the value of the gamma has to increase. Only then you can have the same energy. Now you think a limit. When you are making m smaller and smaller and smaller, that m tends to 0. Then for having the same energy, gamma should be high and high, and it should to approach, gamma should to approach infinity. Okay? If you are making mass smaller and smaller tends to 0, then value of the gamma should tend to infinity. Only then we can have the same energy. So what is gamma? So if m tends to 0, then v tends to c. V tends to c mean this is 0 and something upon 0 is mean infinity. So now there is a problem for the photon. You know, photon is a massless. Photon is not having any mass. Photon is a energy packet as well as it is massless. If it is massless mean the value of m equals to 0. The value of m equals to 0, but the photon having the energy, if m equals to 0, then gamma should be, because m equals to 0. And we know well, the photons, they moves with the velocity equals to the velocity of light. So gamma becomes infinity. Now infinity multiplied by 0. So this is a problem for a mathematics. So that's why we are thinking this equation even not a very good equation, because in case of photon a problem arises, because the massless mean m0, they move with velocity equals to velocity of light, mean gamma infinity. Now what the mathematics tells you, mean infinity into 0 is what? The meaningless. So we have to think about the other equation. So this is again a not good equation. Therefore now we are coming. So before we were saying that E equals to gamma mc square true for the moving objects. But problem arises, you know. If the mass becomes 0, then now think about this equation. This is a very good equation. You know what the equation is. E is energy, alright? Pc is the momentum of a particle or maybe photon. So Pc is the momentum. mc square is the rest mass energy. This is rest mass energy. Now Pythagoras theorem. So E square becomes Pc whole square, mc square and whole square, right? Now this is a very interesting equation. This equation tells us if let I am decreasing this mc square. Like instead of mc square of this value, I chosen the mc square from here to here. Now what happens? Now this becomes the energy. If I cut, if the particle mass more or less, then this becomes the energy. So, going down and down mean mass decreasing, then E is first of all it was like this, then like this, then like this. When totally mass becomes zero, then E comes along this side, mean then E becomes equals to PC. So E equals to PC when mc square becomes 0, mean when m is equals to 0. So that's the case of the photon. Photon is not having any mass. So energy of the photon is then Pc. P is the momentum of the photon. Photon having momentum. And what is the momentum of the photon? Is energy divided by the constant, which is the velocity of light. Okay. So P is here the momentum of the object, and C is the constant. This constant value you remember always. So a particle is, so think the other case, a particle is not moving, mean this was the triangle. Along this side it is the momentum. Along this side this is mc square. This is value of E. This is value of E. Now think the other case. You are making this value smaller and smaller. So E becomes like this. E becomes like this. E becomes like this for this much momentum. And if total momentum is 0, then E comes along this side. Mean E becomes equals to mc square. Or from here, if P is 0, then E becomes equals to mc square. General equation, Einstein's famous equation, mass energy equivalence. For photons, because massless, so energy equals to Pc. So where P is the momentum of the photon. Photon having momentum. So this is a relation between energy and momentum of the photon. That means we are reaching to a conclusion that this equation is very, very good, applicable for the particles in motion as well as for particle at rest, right? As well as for the photon. There's no problem. So E is equals to gamma mc square, but there was a problem, and gamma is equal to theta. Gamma is E by mc square. Now there's another definition of gamma. What's that another definition? Lastly, I'm telling you the other definition. Here energy, there's energy of the moving mass. This energy of the mass at rest. So if you divide the moving energy with the energy of the particle at rest, then you can have the value of gamma. And lastly, E equals to mc square. You can apply in any case for any particle, not for any case, for particle which is at rest, and at rest you are interested for finding how much a rest particle, rest object having the energy, then you find that energy by m and c scale multiplication. Assuming c is here a constant, don't think that c denotes that object is moving with velocity of light. Object is not moving with the velocity of light. The object is at rest. C is only a constant here, and you can have the value of energy. So this is good equation, Einstein famous equation. Energy and mass are interconvertible. But if the mass moves with approximately with the velocity of light, then you use this equation. And for the photon, it is advisable to use that E square equals to PC whole square plus MC square whole square. Okay, thank you very much. If you like my videos, please subscribe my channel. Thank you very much.